The roots of the equation x cubed plus px squared plus qx plus r equals 0 are 1, 2, and negative 3. Find the values of p, q, and r. So there are a few different approaches you could take to this one. One approach would be, given that we know the roots, we know that this can be written as x minus 1, x minus 2, x plus 3, and we could expand this to find those. That's an absolutely valid method for solving this problem. I'm going to show you a slightly different method using the sum and products of the roots here, which you might prefer or you might not. It's up to you which one you use when you come to solving this kind of problem. So we know that the sum of the roots is 1 plus 2 minus 3 is 0. So the sum of the roots is equal to 0, and the sum of the roots of a cubic are going to be equal to minus 1 to the 1, because we're adding together 3 roots. Let's write this x1 plus x2 plus x3. We're multiplying them one at a time, so it's to the power of 1. And then over 1, that's the leading coefficient, and the numerator is step 1 back, which is p. So that means that minus p is equal to 0. Well, that means p is equal to 0. Using the product of the roots, that is x1, x2, x3, multiplying these together, we get minus 6. From the formula, we know that this is minus 1 to the power of, well, 3 things are being multiplied, so to the power of 3. And it's going to be 1, 2, 3 steps back, so that's r. So that means that minus r is equal to minus 6, which means that r is equal to 6. So we've worked out p, we've worked out r. We could then find q in any number of ways. We could use the sum of the pairwise products, or at this stage it might actually be easier just to substitute in a value. So if we now substitute 1, we now have the equation x cubed plus qx plus 6, and we know that when we substitute 1 in, or 2, or minus 3, it's equal to 0. So 1 cubed plus q plus 6 is equal to 0, which means q must be equal to minus 7. So p is 0, r is 6, and q is minus 7. As I said, there are multiple different methods you could use to solve this. This isn't the only one, but this is a nice alternative to having to do a lot of algebra here with expansion, using the sum and the product of the roots rules that we have seen.